Hello, I'm Anjali. I'm from the software engineering course of Set 2, and my topic is going to be bugs, the cost of bugs, the impact of bugs, and how to mitigate bugs if they do occur in your software. To get started, I wanted to ask you that if you've ever gone through an app and seen a feature thinking if it's meant to be there or not. Like when you go to search something on Google, you feel that I am feeling lucky tab. It seems pretty useless when you go through that feature and you remember thinking, was it always meant to be there or is it just an Easter egg? Similarly, I wanted to talk about the scenario where Gmail was first initially getting started. When users went to send emails, it would occur with a 5-second delay. So it made the users frustrated, and how the developers thought to deal with it was they used this 5 second as a grace period and added an undo button to stop the emails before they were sent. This made the users think it's a feature rather than a bug and made the customer more satisfied. This was one situation where the bug was handled effectively and it didn't end up causing catastrophic damage. In this presentation, however, I'm going to go through cases where it actually ended up being a catastrophe, what bugs are, and also how to deal with them. So, first, I would like to start off by defining the terminology when we refer to bugs. Let's start off with what a bug is. A bug is a simple error in your code. It often cannot catch the eye, or you might miss it when you're coding. One simple example is in a recipe book. Let's say it's written you want to use 2 cups of salt over the normal 1 teaspoon. This simple error where it's mentioned 2 cups over a teaspoon is a error. This er- this bug, this bug leads to something called an error. The error is the part where it ends in the system and it behaving in a way it's not supposed to. This error, let's say when you compile the code, it will end up giving you results that you don't want. The part this now ends up in something called a fault, where this 2 cup recipe book gets printed and it leads to the system not acting the way it's supposed to. Failure is when the user follows the recipe, makes it, and ends up dissatisfied with the recipe. That's a failure. It's not behaving as it's expected to. This terminology, now that we know them, is very crucial to manage them properly. These bugs can occur in every single stage and not only in the development stage of the software development lifecycle. So let's get started with the first stage, that is requirements gathering. We know that in the requirements gathering stage, you're communicating with the clients based on their needs and trying to understand them and document them properly. One or types of bugs that can occur in this stage is misunderstanding what the client wants. Or even if you understand what the client wants, you don't get enough details to get it perfectly right. This ends up causing a domino effect where, since you're understanding the requirements itself wrong, you end up creating the whole code and deploying the wrong code. This could create a lot of reputation damage as well as monetary loss for the company. One way to deal with this is you document that requirements properly and you constantly communicate with the client and make sure you have every single requirement to the T. Next step is the design process in the software development life cycle, where you've understood all the requirements that are present and you design a flow for the software. One bug that can occur in this phase is the poor system architecture, where it doesn't account for every software requirement that you have, or it is designed in such a way that it's not scalable and it cannot accommodate for more users or more functionalities. This can end up in causing us more cost, in the sense that you might have to go back to the code after it's deployed and rework on it. One way to mitigate this is you have design reviews. You go through the design multiple times, you create multiple versions till you have it just right. You can also forecast your future needs and make sure that it is scalable, it's secure. Then moving on to the development stage, now that you've designed a perfect architecture, is the development part where you implement the code. Here, the bugs are very self-explanatory. It can occur in the form of coding mistakes. It can also occur as if the developers do not practice proper standards, and it could lead to uh, a poor quality of code. The more defects that go unnoticed in this phase, the bigger the error or the bigger the failure that ends up happening. The way to mitigate this is having code reviews from multiple peers and making sure your code works perfectly as it's supposed to before moving on to the next stage. One way this can be done is through pair programming. When there are two people working together, reviewing each other's code, and it provides a fresh set of eyes to your code, and it can help improving the quality of your code. Next stage is the testing stage. This is the stage where you test whether your code is performing every single requirement as you need it to. This is the stage where the most number of bugs come out. So, what are the bugs that can occur here? Is your test cases don't cover every single functionality that you need it to. It doesn't cover every end case, or it doesn't stress test the code properly. And the bugs that can also occur here can be due to the lack of automated testing, in the sense that if it's manual, it has more room for error. This can cause, if not done properly, if testing is not done properly, it could cause the bugs to go unnoticed from this stage and into deployment, which could be catastrophic. One way to mitigate this is obviously automating the testing process to minimize the human errors that can occur here, and also accounting for every extreme tests and making sure it is stress tested before deploying the software. Now, the bugs that can occur in deployment is misconfigurations, untested changes, and lack of rollback strategies. Going through untested changes, in the testing phase, let's say you came across a bug, you modified the code such that the bug doesn't exist anymore, but you never went back and tested it to see if it still works or not. And you still deploy it thinking that the error has been solved, it could lead to errors if it wasn't solved properly. Also, if there was a bug that goes through and the deployment wasn't done in such a way that it could be rolled back, it could lead to a lot of damage. It could lead to financial losses and downtime, which could lead to customer dissatisfaction and lack of loyalty. The customers won't be loyal anymore. Ways to mitigate this is implementing a proper rollback mechanism and also continuous deployment in such a way that you write code, you deploy it, and if it doesn't work as it's intended to, you roll it back immediately. You do this process continuously till you get it just right. Next phase is the maintenance phase, where a working code has already been deployed and you're trying to maintain it. Here comes the bugs that can occur, which are problems with the legacy code. Legacy code has been there for a long time in the software. It has been occurred years before the developers that are currently working on it. And this code can be hard to understand if there's no proper documentation on it. And it could accumulate a lot of technical debt. Technical debt in the sense that errors pile one on top of one another, and it makes the code a complete failure. Consequences of this is you need a lot of support to go back and work on everything that was wrong, to fix everything that was wrong because it wasn't right in the first place. This could also create a lot of performance degradation because the code is in downtime and the customers don't get the same access as it would if the code was right in the first place. One example of this was the Y2K bug. Y2K bug occurred when you were the all the systems and softwares were dealing with the fact that the year was changing from 1999 to 2000s. A lot of code needed to be changed just for that simple change in the years. This could be avoided if there was a future forecasting of the needs and the software was built keeping that the year would change in mind. One way to deal with this is continuous monitoring and proactive maintenance. Proactive maintenance, again, meaning you forecast your future needs and you make changes early before before the errors occur. Instead of reacting to the errors, you forecast them and you proactively maintain them. Now that we're done with going through each bug or the types of bugs that can occur in each phase, I wanted to compare the costs of them. So, as we might know, that when you go through and detect bugs as early as possible, it will be as cost effective as it can be. The more further down the software development lifecycle you go, the cost increases exponentially. We can see from the graph here that it would cost you 1 times more in requirement gathering phase over the deployment phase, where it can go way more than 30 times because you have to go back and recover and undo changes. It can cause reputation damage as well as financial loss because it wasn't right from the first place. You have to go back and work on it again. This can be catastrophic, and I wanted to use an example to explain this. There was a Mars orbital spacecraft that was made by NASA. The code was done, the rocket was made, the spacecraft was made and sent into space. However, all the scientists working on it didn't review a tiny unit conversion bug that occurred. It went undetected, and the 327 million dollar spacecraft ended up crashing into the Mars atmosphere and was destroyed. One simple unit conversion bug, if went through by scientists, if this tiny conversion bug was detected early in the coding process, it could save millions of dollars. This is why the earlier the bug is caused, the cheaper and safer it is to fix. Dealing with bugs. I have gone through multiple mitigation strategies, but I wanted to bring it to one place. I have mentioned you have to do rigorous testing. You account for every end case scenario. You stress test your software before moving it on to the deployment stage. While you're writing your code, you have multiple people go through it, and you adopt a process of continuous integration and continuous development where you simply write code multiple times and deploy it. And if it's faulty, you roll back. You also automate the process of testing and apply many debugging tools to make sure it's working perfectly as it's supposed to. You prioritize security and error logging. You prioritize error logging because when you make changes to your software, it's essential so that to document it so that you can go back to that and backtrack to see where the changes were made and where the error was made. More importantly, it's important to foster a culture of quality assurance. This ensures that all your peers and you are collectively working to make good quality software and not just making a poor quality software fast. I would like to conclude by saying that bugs are inevitable. Errors are bound to happen, but it's important that we stay aware, recognize that bugs exist, and keep on testing them in every stage of software development. This not only saves us money and reputation, saves our reputation, but it makes sure the code that you're developing is high quality, reliable, secure, and user friendly. Thank you.